So today I have a couple of things that I have in mind for today. I was going to start off talking about some general issues in what we call accounting in this class, but they're more like financial responsibilities you may run into as a medical assistant working in a small practice. Um, And then and when Michaela joins us, we'll go back to calculations because I know she has some questions. She's told me she has questions about those. So I'd
Okay.
like to go back to those. I have an in-class activity for you guys to do today. And my idea is that the two of you will work on that together and help each other with the problems. They reflect to a great extent what you'll see in the assessment. So there's a
Oh,
couple of
okay.
basic principles that I want to make sure that you have an understanding about before you get into that in-class activity that you'll be working on. Okay?
Perfect. I actually do have a couple questions on the assignment as well. So
Super.
um, I think I'm reading too much into it, but I just want to be sure.
Yeah. Part of the problem is that, as in real life, there is information in many of those that, while critical to proper treatment to the patient, are not relevant to the actual calculations.
Okay.
Okay. So that's the thing that's one of the things I wanted to focus on today and help you guys understand um, uh, how to navigate through these problems and pick out the things that are necessary to do the calculation, especially flow rate calculations, how to do those, and not get sidetracked
All
by
the added fluff in that.
and
And
that's critical. Yeah,
I think that's what's confusing me a little bit is all the added stuff. So I'm just wanting to make sure of the, like you said, the necessary information we need from the problem.
right.
So it's
Yeah.
this is Tell didn't really get into the drop rate stuff or flow rate with everything in pharmacy. What was that?
208.
107. Oh, 208. Yeah, we did a couple problems here and there for the IV, the like drop rate with the I believe it's like the IV and R. So, or wait, no, it's
Mm-hmm.
the V.
VRT, vert.
Yep,
The
yep,
vert
vert.
circle, yeah.
Yep,
Yeah,
the vert circle.
right. I don't usually go into that. I just go to straight to the formula. So, but yeah, that's something to consider. Um, and I'm sure, she had a lot to cover in that class. It's difficult sometimes to cover all the bases. And having taught that class, I know that it's hard to get into some of these because um, they are confusing at the outset until you get the logic.
Yes, it
And
was very
then they're a
confusing.
lot easier. Yeah.
And I think that's what's causing my confusion right now
Right.
too. Because I feel very confident on all the math we've done through the first couple weeks so far.
Mm-hmm.
Bless you, bud. So I was like, huh, I usually don't get this confused with math problems, but this this is new to me, so it's
Right.
good. It's good to learn.
Yep, it is. So let's look at the beginning here. Note, you remember I'm going to just pull up discussion 1 to start with, looking at this accounting issue, what they call accounting, but really isn't actually accounting. There are times and situations in which you will have potentially be asked to take on some responsibilities with with the finance. And to some extent, that has to do with practice size more than anything else. In a small practice, and I'm thinking about maybe like a dermatology practice that I used to go to. There was one practitioner and a couple of medical assistants. And there was always one of the medical assistants on the desk. And so taking in patients, booking them in, making certain that they got the copay payments, getting insurance information. You've had the insurance specialist class, I assume?
Yes, I believe so.
Yeah, I can't remember which of those classes that is, but by now, as close as you are to graduation, you should have had that.
I
So
think I did. That sounds
probably could
very
tell.
familiar.
Yeah, and so the class, the issue is that we have to get all of that information, and we have to record it properly. So this is the sort of administrative tasks. As I said, the big black medical assisting book that I call the boat anchor has a lot of, has sections on the administrative duties of a medical assistant. In a large practice, and I'm talking about up here, a practice like Associates in Family Medicine that has, a dozen different locations and probably 50 practitioners and probably at least as many medical assistants. They'll have clerical staff and office staff that will handle all of that. And your job will be to function as a clinical medical assistant.
Okay.
And in fact, the medical assisting exam that you take to get your certification is the CCMA, the Certified Clinical Medical Assistant exam. There is a medical exam for the administrative assistant as well. And I think on even the CCMA exam, there may be a few questions that are related to sort of office procedural kinds of things. But there's a couple of things that you do. One of those is you may be faced with helping with the daily, what we call accounting functions. And that really is accurately entering income, which we call a credit in accounting terms. Accounting is divided. We talk about income and expenses when we're talking about our daily lives, but the accounting terms are credits and debits. Credits being money coming in, debits being money going out. And there are lots of other various accounting functions and accounting approaches that probably would end up being transparent to anyone just doing all of this kind of work. In terms of accounting, we have most small businesses will use what we call the cash basis accounting, meaning that you don't book income until you receive the check.
Okay.
And you don't book it until you get all your money. And it's not finished until you get all of that money. There is something called the accrual basis, which puts the money in as soon as you receive it. As soon as you receive the first payment, you book the entire transaction, and then you maintain a separate account for the amount due. And so you amortize the receipt of that money over time. This is an accounting function that's a bit abstract to most of us, because most of us think of accounting as like keeping a checkbook. And in a checkbook, you write in your checks, you write in your deposits, and that's it. Anything that goes out, and nowadays electronic transactions and so forth will go in there as well. Um, that's the way you have some idea as to, if you keep decent records, that's the way you have some idea of the amount of money you actually have.
Yep.
And we all understand that that any sort of going concern, whether it's a household or a business, your credits, your income, need to exceed your debits, your expenses, the things that you pay out. So it's the same sort of thing in a business, except the accountants handle various things different ways, and that's one of the reasons that your business would have an actual accountant, and the role that you might fulfill is closer to a bookkeeper. But again, it depends on the practice. A large practice is going to have its own financial, usually a central financial operation. And then the administrative folks at each site, like a multifamily site like AFM has, each site will have someone at the desk that will record each of those transactions as they come in into a common system.
Okay.
So those are the kinds of things that you would do. So you get the administrative, when you do the administrative stuff, you do have certain pseudo-administrative duties, even as a clinical medical assistant. And those are accurate record keeping. Things have changed immensely in the last couple of decades in terms of how we keep our records. When we were mandated to go to all electronic records, and this theoretically has happened already, but in practice, often it's a bit spotty.
Mm-hmm.
But when we went to that, it made sense to have record systems where you would have, for instance, at the practice that we go to, the rare times that we need a doctor, we used to go to a lot more when my mother-in-law was with us, because we had regular appointments for her. But what happens is you walk in, and the medical assistant, who's usually the first person you see when you're taken back into the treatment area, comes in with a computer. Mm-hmm. And that computer is connected into the office system, and everything that they put in, and they'll put in whatever you say that their problem is for the day. They'll ask questions and put in your answers. They'll take your vitals, enter all that data, and they will go back and provide, and that information is then immediately updated into the system so that the practitioner on their computer also has all that information. And the systems are getting much more sophisticated, basically as we speak. There's some of these systems are and specialized. Mm-hmm. If you go into, for instance, an ophthalmology clinic for an eye exam, they have a totally different set of data that they take. Usually you won't get your vitals taken unless there's a reason to. Such as a few years ago, I had cataract surgery, and that's the only time they ever took a vital at the ophthalmologists.
That makes sense.
Yeah, because they were about to give me happy juice, to make it a little more tolerable.
I couldn't imagine. Without happy juice, that wouldn't feel very, very good.
Yeah. So we in a general practice. Now you go into a specialty practice, say, a dermatology practice. They may or may not do any vitals. Often they will, um, but not necessarily. So it's a totally different set of data uh, that you're accumulating in each of these. So it is something, those administrative medical record keeping systems are something that when you go into a practice, you will not be expected to be already expert at whatever system they're using, simply because there's no reason to believe that they'll be using the same system that you've had elsewhere, and you're not actually trained on these systems and from in your schooling. You're given these model systems that function, ask the same questions, but they just function slightly differently. So you have to learn that. Part of your training when you go into any position will be learning the electronic health record system that they're using, and becoming familiar with it. And that's something they'll expect you to learn in a hurry. And you probably will, because it's not going to look all that more complex unless you go into a specialty office. It's not going to look all that more complex than what you've already seen in your schooling. So, but nonetheless, it's a critical task, because I just read an article this morning before class that looked at a study that was done by one of the academic groups, and I can't remember who, that looked at patient records and talked to patients about the accuracy of their medical records. It seems kind of funny, but you can actually, theoretically, you can review your medical records at any time. That's part of HIPAA.
Mm-hmm.
You are supposed to be able to look at your medical records. And excuse the noise in the background, please.
Oh, no, you're fine.
But you can look at you look at that, and what was found was about 20% of the patients found errors in their own medical records. And we're not talking
Wow.
about patients who are trained at all in medicine, but they're seeing information left out, like allergy information.
Oh, that's important too.
It's
You
critical.
have to have that documented.
It's absolutely critical. But it is, and you know, this is not to take a slap at anybody about anything, but it really boils down, what it boils down to is that practitioners are so busy. It used to be a case when I can remember when our kids were young and we'd go and take them in for their well baby check. After the appointment, we'd hear the doctor dictating notes that were then transcribed. It would be transcribed by a medical assistant, someone who was responsible for that transcription, into their record system. Now, there you're dependent on the physician not being distracted, remembering everything.
I was going to say, and having a great memory.
Yeah, they have to remember everything. And so the mistakes that are found, a lot of them are, you might argue, aren't necessarily important, but in reality, they're very important because accuracy is key. Insurance demands it as well. But when things are left out, like a diagnosis or a medical history issue, this can affect the care that you receive. So the the thing that I'm trying to get to here is that that our current system where everyone is entering things real time as they receive it. The only thing you need to watch out for is typos.
Right.
And so we really do have to, have to do that. But let's go back to these administrative roles. One of the things um, that you will see when you take the medical assisting exam is some clerical issues, completing forms, answering phones. These are all sorts of things that you have to do. Keeping a record of patients when they enter the medical office, dealing directly with patients that you're not actually doing anything clinical with. So you're dealing with people in the office at times. So you have to remember that this is a necessary part of running any business. If again you're fortunate enough to be in a small practice, these can be very fun places, very intimate places to work. You may find yourself doing some of these things and filing insurance claims. Now, one of the things mentioned here in the discussion is budgeting and payroll.
Handled payroll before, but never budgeting.
Payroll is a specialty operation because you have to remember all of the various components that go into it, not just state and federal taxes. You may have local taxes. If you live in a large city like Denver, you'll have local taxes. If you happen to be there, you have to remember Social Security. You have to remember unemployment insurance. All these things that go into a payroll, as you know, can get to be a lot. So, in a small practice, you're probably going to use something like QuickBooks Payroll, to be honest. In a large practice, you probably won't be doing payroll because they'll have somebody handling that full time, because that in a larger practice where you've got potentially, like a group practice where you have, scores, maybe even hundreds of employees, that's a full-time job.
Oh yeah.
Full-time job. But you might, in a small practice, you might be, or even in a local office for a larger practice, a small local office with maybe 3 or 4 practitioners and a dozen or so assistants. You might be collecting time card information, hour information for employees. And when it's more complex by having part-time employees, then it just gets to be a lot of records. But they're necessary. And those records too need to be accurate, for the simple reason, if nothing else, then the IRS gets kind of really irritated when they're not, as well as your employees. So you have to be able to look at that. Now, as for expense reports, you might have expense reports that need to be filled out, which means maybe your primary comes in and says, here's a bunch of receipts because I've been out buying supplies, whatever. You may deal with suppliers and inventory, because of course, if you think about it, the inventory of supplies that you need to run an office is enormous. And someone has to be following that and keeping a record when you need to order another, 5,000 alcohol wipes, or, sterile bandages or syringes or whatever, the many, many things you have to order. And you have to remember that these things, you don't order them and have them magically appear on your desk instantaneously.
Oh no, it takes a couple days. Even weeks,
It
depending
can.
upon
Yeah.
what you're ordering. I did a lot of basically what we're talking about for a pharmacy. It wasn't a medical practice, but it was for a pharmacy, and I handled a lot of the ordering too. So it was very interesting to learn.
Yeah.
And I feel like I can put two and two together a little bit with medical assisting, so that helps as well.
Yeah. And having that experience to make you more valuable and when you're interviewing and looking for that job when you get finished with your program, I would emphasize the fact that you have these other skills that you'd already practiced in a medical setting. A pharmacy is a medical setting. So, it's important to do that. As for budgeting, I question really um, whether you, even in a small practice, would actually be central to budgeting. However, you may be asked to compile and categorize expenses for a budget process. So, be aware that that's a critical aspect of any budgeting is to know what it is you're budgeting for so that you don't forget. You can lump a lot of stuff, general supplies can be lumped together. Um, and sort of that sort of thing. But nonetheless, somebody has to often figure out, what did we spend last year? It's easy not to pay attention. I used to, when I was teaching down at the Denver campus of College America a number of years ago, one of my duties, I was a full-time employee. One of my duties was actually making certain that we had all of our supplies for our medical program. So that required that I not only have a system of determining what was in stock, but I needed to know what was being used, and I needed to watch. Fortunately, we were scheduling our classes um, 3 months in advance. So I always knew the next 3 months worth of classes that were going to
Okay.
be taught. And I had a pretty good idea of the size of those classes at that time. So I could adjust my ordering so that we always had everything we needed, plus just a little extra so that we didn't have a lot of stuff sitting on the shelf, because some things, like normal saline for the injections class, expire.
Oh yeah.
And at least in theory, um, in theory, those expiration dates are a bit squishy. And so if you've got something that expired in June of, say, 2020, and it's July, it's probably still good, but it's not good practice.
Right.
And it is technically illegal to use such things in a clinical setting. In a school, a little different. But nonetheless, we have to maintain um, an understanding. You saw it in the pharmacy. You don't over order any supplies because
Mm-hmm.
they all have expiration dates, and it's illegal to sell anything that's expired. So, and even if you understand that many of those things, as an example, um, many drugs, all drugs have expiration dates. That's an FDA rule, and that expiration date is um, up to 5 years.
Okay.
Now, I'm here to tell you that things like aspirin, if they're properly stored, will sit on a shelf for decades and still be quite viable. I worked for a pharmaceutical company for 20 years, and we had an aspirin product called Emprin. I worked for the Burroughs Wellcome Company, which is now part of GlaxoSmithKline. We had an aspirin product called Emprin. Since it was an OTC product, along with Sudafed and a couple of dozen other things, we just had a stock room, and the employees could just go down and get a bottle or a box whenever they wanted. So I took some Emprin home, and it's still on the shelf. The expiration date on the bottle, 1985.
Oh my goodness.
And it's still fine. Now, I'm a chemist by my education and experience, and I can tell you when aspirin goes off. And quite frankly, it just smells very strongly of vinegar.
Huh.
When it only has a slight vinegar odor, it's fine.
Okay.
And this stuff is still fine. And,
wow.
1985 expiration date, it's 30 years out of date already. Or 35. 35
wow.
years out of date. But it's still good. Now, would I give that to someone that I didn't know? No. Would I take it myself? Yeah, I don't take them. So obviously we don't take much because it's been on the shelf that's long in our house. But nonetheless, these things last. So we do have to maintain inventory records even in our practice. Someone has to maintain them. That might be something that even as a clinical medical assistant, you're asked to do, because of course, many of those things are going to be clinical supplies. We have to know when we're about to run out of 3cc syringes.
Right.
We have to know when we're about to run out of alcohol prep pads and other sort of clinical supplies. Kayla, you're on.
Hello.
Hi, welcome to class. I'm just discussing with Ariel some things about the administrative duties that are referred to in the title of this course as accounting, but they do fall, many of them fall under that rubric, but they're not truly accounting duties. Right now we're talking about inventory. You can go back and catch up with it. We've been talking for about 30 minutes. You can go back and catch up on it after class when I get the recorded class posted. Okay?
Thank you.
Okay. Are you doing okay?
Yeah, I'm doing better now. They kind of like continued the court thing, so it wasn't as bad as it was going to be, but
yeah,
got that out of the way.
yeah, that's no fun, having those continuations, because you want these things finished.
Yeah, exactly. Thank you for asking.
You're welcome. It's a tough time, I know. So anyway, let's go back to this. So I was just talking about one of the things that's in your discussion this week is things like payroll and budgets. I really, the issue for me is that budgets are really the responsibility of the senior management staff of any organization, because they're the ones that theoretically are going to be setting such things. But the issue is that you may be asked to participate in that process by providing information. What did we, give me a summary of the patient co-pays for the last 3 years in order to, and give me a summary of how much we spent on these kinds of supplies in the last 3 years, so that we can set our operational budgets and look at where we need to be in order to keep the business viable. A viable business, of course, is one that has more income than expenses, more coming in than going out. But the actual accounting process is going to be different from practice to practice. So budgets might happen. Payroll, you may assist in that process. You're unlikely to actually do payroll unless your position evolves into one of sort of financial management, which does happen. But most organizations will either have an existing financial administrative staff, or they will have someone who's trained in doing these things. And often they'll have these things hired out. Years ago, and I suspect it's the same now, there were several sort of contract organizations that would handle things like payroll for small businesses. And they were pretty reasonably priced, at least at that time. So it will be something to think about. Okay. So you can, if you have any questions about anything when you see it, Kayla, just email me.
Okay, thank you.
Mm-hmm. So let's go once again and look at, let's take a quick look at the second discussion of this week, which is where I want to go into next, which is dosages and flow rates for parenteral administration. Parenteral simply means, is usually translated as injections. And so we're going to leave it at that. Technically, it's anything that bypasses the stomach. But for the most part, we're talking about things that are going to be injected via some form of device into the patient. And flow rates refers to infusion. In other words, dosing over time. Dosages are important there as well. You can also have, you can also be calculating dosages for a single injection. But a lot of times what you will hear from your practitioner who orders it, you cannot give these things on your own as a medical assistant. You only can do so under the direction of a licensed practitioner. They will tell you what to do. If they want, an injection of some drug, they will tell you how much to give. And then it's just up to you to do it. And most of the time that I have been given things, it's been vaccines and stuff, boosters like the Tdap, which we're finding that need to be repeated as people get older. Just little things like that. So and a lot of those even come as pre-filled syringes. So you just basically poke a patient and give them the whole contents. So a lot of it will be there, but what we're going to be looking at in the assignment as well is something called days supply. Now let's take a quick look here at the assessment. There is no accounting. There are no accounting questions in the assessment.
Oh, thank goodness.
Yeah. The only place you're going to be running into that this week is going to be in the discussion.
Okay.
The first discussion. So what I'm going to go through now and looking at this is looking at this week's assignment and looking at both days supply calculations and parenteral calculations and review them. In resources, Kayla, you will see something called the week 3 concepts. This is something that I went over in the video, and it is recorded on the video on Monday. And I have posted that document that had 6 problems at the end, and I posted that with the full with the solutions to those problems as well. So you can take a look at that. And again, if there are problems, let me know. If we need to set up a short Zoom session to discuss things, if you're having lots of problems, let me know and we'll find a time over the weekend that we can do that. Is that okay?
Yeah, I forgot her name. I've been having Zoom sessions like on the side as well to get help with these.
Great. So you're talking to Laura?
Yeah, Laura.
Super, super. Yeah, she knows this stuff pretty well. Okay. So let's go to the assignment document again. And what I want to do then is share that. If I can find it again. I always have trouble finding it. There. All right. Here we go. So let's go back to the top. So this is our basic formula for flow rate. Volume over time equals flow rate. Okay, this is milliliters per hour. If we're using an infusion pump, it's milliliters per minute if we are using a manual feed system, gravity-based feed system, because the only way we can adjust the flow rate is by calculating the number of drops that have to go into the patient per minute to equal that flow rate. And we'll get to those calculations again quickly in a bit. So the important thing to remember when you're looking at a flow rate is the only thing you need to know is the volume and the time. It doesn't matter if there's all sorts of other information in there about the drug that's being used, the concentration of the drug being used. If you have the volume that has to go in and the time over which it has to go in, then that's the only thing that counts. This short, easy example here at the beginning is 1 liter of normal saline over 24 hours. So in the absence of any other information, such as a specification of an apparatus to deliver a certain drop rate, we assume it's a pump, and they always deliver in milliliters per hour. So if you don't see anything about drops, you know, a drop apparatus called a venoclysis set, then it's a pump. So in this case, we've got 1,000 milliliters, 1 liter. You have to convert it to milliliters. Remember, we want milliliters per hour. So we're going to deliver that over 24 hours. Now, when we do that division, what we get is a fractional number, 41.67. These pumps cannot be set that fine. They can only be set to milliliters per hour, whole milliliters. So we round it off. But I'm going to emphasize again, no matter how many calculations you need to go through, when you're doing one of these things, you don't round off until the very end, because every rounding creates a small but cumulative error. So we minimize the error by, doesn't matter. I mean, if you do this on a calculator, this is going to be 41.6666 forever. So we just round it off to 42. Okay, so all these problems in the assignment will be a variant of this. D5NS, again, the identity of the liquid is unimportant. It's critical to give the right liquid in terms of patient safety, et cetera, but in terms of the math, that's not an important consideration. The only consideration we have is the total volume and the total time. Okay. D5NS is a mixture of dextrose 5% and water, and is dextrose 5% in normal saline. So it's 5% dextrose and 0.9% sodium chloride. This is a standard IV solution that we give to patients. So let's take a look now at drop rate. In this particular case, it's a similar formula. Remember the rate, if we go back up here, flow rate, or FR, is volume over time. They used a capital T because that tells you that tells us it's hours. We go down to drop rate. We want to know drops per minute. And as I said to Ariel on Monday, and said in the video, when we're using a pump, we need to be very careful about where the bag that this drug is coming out of is placed. With a pump, you're sucking things out using a peristaltic pump, so it doesn't matter. The bag can be lying on the floor, which of course you would never do, but it could be, and it'll just pump the stuff into the patient. We generally hang the bag above the pump, and make it, we want to keep it not only clean, but we want it visible, easily visible. But when we are doing a manual administration, which basically is by gravity flow, the bag has to be 36 inches above the heart of the patient. That's the standard. But here, we're dividing volume. Again, we just need to know the volume, and we're dividing by time, small t, that means in minutes. The DF is the drop factor. Drop factor is the number of milliliter or drops in a milliliter that will be delivered by the venoclysis set. These come in 4 different ratings. 10 drops per milliliter, 15 and 20 drops per milliliter. And then we have something called a micro apparatus, which is for 60 drops per milliliter. We use the micro apparatus when we are using flow rates that are volumes going in that are approximately 1 milliliter per minute or less. And we use the micro apparatus. It's all about error control. If you've got 1 milliliter per minute and you have a 10 drop per milliliter apparatus, that means that you're going to be putting in 10 drops per minute. If you're off by 1 drop, that's a 10% error. That's already approaching the unacceptable. So if you are, however, using the 60 drop per milliliter, then you've got 60 drops per minute, or 1 per second. If you're off by 1 drop, that's a very, very small error, 1/60th. So we don't, we look at the volume that's going in when we have a choice. A lot of time, all of your examples that you do and the problems you'll be given will tell you what the drop factor of the apparatus you're going to use is going to be. But in practice, you're going to look at the rate that it's going in, and you're going to pick the appropriate apparatus to minimize the risk of error in that rate. When would you use a 10 drop per milliliter? When you have a volume of 2, 3, 4, even 5 milliliters a minute, because we can easily calculate. And there's the apparatus, you'll see if you look at this video here, the apparatus has a dial, a little chamber and a dial in the middle of in the line that allows you to control that volume, and it's calibrated. So you can get very close to the volume you want by using those calibrations, and then count in the same way that you count pulse. but I know you're used to seeing in your vital signs class using a pulse oximeter, uh, where where you actually read the pulse rate as well as the oxygen saturation of the patient. We don't have anything like that on a venoclysis set. Used to be that all nurses and medical assistants would manually take a pulse at the wrist or perhaps at the ankle, and count the number of heartbeats for 15 seconds multiplied by 4. Well, here you can do the same thing looking at this apparatus. You can count for a specified amount of time and then get very close to the appropriate drop rate. So let's again use an example. Physician is ordering 150 milliliters per hour IV and using a set that is 15 drops per milliliter. Well, this 15 drops per milliliter tells us that we're going to be doing this manually. So we want to be calculating the time in minutes. So in this particular case, 150 milliliters in an hour is 150 milliliters in 60 minutes. Now they put all this together in one calculation, but what I'm suggesting is that you do these separately. Do this calculation first. If you divide 60 into 150, you're going to get 2.5. If you multiply 2.5 times, that's 2.5 milliliters per minute, multiply that by 15 drops per milliliter, milliliters cancel out, and what you end up with is drops per minute. 37.5 is the result. Well, you can't count half a drop. We round this off. Now, there are two schools of thought on rounding here. One is that we always round up. There's a risk with that. If you had 37.1 and rounded it up to 38, that would be a bigger error than rounding down to 37. So I urge people to follow the appropriate rounding rules from math. So if this is a 5 or more, it goes up. If it's less than 5, and it doesn't matter what follows that number. If it's less than 5, you drop it. Your assessment may grade you wrong. If you do that, I will go back and look and correct that. But I do believe that, that we minimize error by following the rounding rules out of mathematics. Okay, so what we have is, again, here's an example. Dextrose 5% in water, 250 milliliters over 6 hours using a 20 drop per milliliter set. Okay, so that tells us, again, we know we're doing these drop factor, drop rate calculations. So what's the drop rate? Well, we need 250 milliliters, 6 hours is 360 minutes. Make sure you do that calculation correctly. So this is going to be less than a milliliter a minute. So I would have used a 60, a microset, but nonetheless you follow their instructions here. So that's really a caution. Just be very careful to remember that when you're using this set and you're given a time in hours, you always convert to minutes. Okay, and then multiply by the drop factor. The drop factor will be given to you, so you don't even have to give it any thought. Okay, so it's the same with the rest of these. Let's take a look here. We have a something here, 10 milliequivalents of potassium chloride. Remember, you don't care. You're looking what's here. We're looking at a volume and a time. Okay? And the time is 12 hours. So you need to multiply that by 60 and divide that into your 1,000 milliliters. So this is an example of information that, while it's critical for patient care, is irrelevant for calculations because it's volume over time. With the only wrinkle is that, whether we're doing this manually or using a pump. Same with this one down here. We got vancomycin 1 gram and 250 milliliters over 4 hours. We don't care about vancomycin. We care about 250 milliliters. Make sense to everyone?
Yes, I was definitely reading too much into it.
I always do that too. I make it too hard.
Well, and then I was freaking out about the milli equivalents. I was like, I don't understand this.
Yeah, we have several different ways of calculating concentration and in calculating potency. Milli equivalents are used for electrolytes such as sodium bicarbonate, potassium chloride, and other kinds of things. It's a chemical term and is absolutely, again, when you think about it, we deliver in terms of volume and time. These, if you do the calculations, disappear.
Mm-hmm.
So the relevance of this is only gives you a concentration. You'll see this with units as well of things like heparin or injectable penicillins and other injectable antibiotics. We'll see units. The units, milli equivalents, if you're a chemist, can be converted easily to grams or milligrams.
Okay.
In this case, units cannot. There is no weight equivalency because units are determined by a biological assay. So it's a measure of potency. And when you think about it, since we always dose in terms of milliliters, the potency measure is irrelevant. Okay.
Do you think we could do one just to have like one as a example?
We will.
Okay.
Okay. I plan to get there because there are some places here. There's some types of calculations here where you may have to actually go back to what is being told to you. But we will get to that. And so let's go on from here. All of these, all that you're interested in is the volume and the time. So here we have, it's irrelevant that we have azithromycin 500 milligrams and 100 milliliters of sodium of normal saline, because the only thing we care about is this volume. And now that we see that there's a drop factor thrown in here, we know that we have to convert the hour to minutes.
Okay.
So let's go down. Now here's an example of where we can do some work looking at the dose. A relatively simple example here. And I say relatively because it probably looks more complicated than it is. So you want this patient to receive 1,000 units of heparin over 24 hours, not per hour, but over 24 hours. So you get a bag that's 1,000 units and 500 milliliters of normal saline. So we want to calculate the flow rate. Okay, so quite frankly, we can ignore this whole discussion early. The important thing is 24 hours and 500 milliliters, and we can go straight there. But we can approach this a slightly different way and look at what does this tell us about the number of units per hour. So what we're wanting to know is that the case. So if we're putting in 1,000 units over 24 hours, then we're looking at dividing 1,000 units by 24 hours and getting 41.67 units per hour. Okay? Don't round off. Keep that number.
Okay.
Okay? So we go down next to the next step. If we have, so now we have this, it becomes a kind of, remember last week we were using the formula dose prescribed divided by dose on hand times the vehicle times quantity, right?
Okay.
So in this case, dose prescribed is 41.67 units. Okay, per hour. 41.67 units per hour. We just calculated that. So that's the dose prescribed. The dose on hand, we're told up here in the problem that we have 1,000 units. That's the dose on hand. And the quantity or volume is 500 milliliters.
Okay.
So we have dose prescribed, dose on hand times Q, quantity. So we divide, so we take this calculation and just do the math. You know, if you were doing this on a calculator, you wouldn't even round it to 41.67. You just leave it at 41.6 blah all the way out.
Right.
So we now calculate 20.84 milliliters. One thing missing from this example is that we have to round that off to 21.
That makes sense.
Because our controller, there's no drop factor here. So
it's a pump.
So it's a controller. So it's going to be milliliters per hour. So we round that off to 21 because that's all the controller can do. We can't adjust that to any finer than that. So we round that off. Kayla, is this making sense?
Yeah.
Okay. So let's go into slightly different. The practitioner is going to order 1 milliequivalent of potassium chloride per hour for 8 hours. So you have a bag that has 10 milliequivalents of potassium chloride in 1 liter, 1,000 milliliters of normal saline. So what's the flow rate? Okay. We're told that the patient dose is 1 milliequivalent per hour. We don't see a drop factor, so this is going to be a pump. So we know that this patient is going to get 1 milliequivalent per hour. We read that right off the order. So the volume, if we look at this now, the dose prescribed 1 milliequivalent per hour. The dose on hand is 10 milliequivalents. And the volume, the quantity is 1,000 milliliters. So again, dose prescribed, 1 milliequivalent. Dose on hand, 10 milliequivalents. Note, milliequivalents disappear. So we don't care what a milliequivalent is. Right?
Cool. I don't like that word.
Yeah, they disappear. And then we multiply that by 100. Well, 1 over 10 is 1/10. So times 1,000 is 100 milliliters per hour.
Okay.
So for 8 hours. Now, in 8 hours, we're not going to use the entire bag. That's okay. We don't care because the doctor didn't order that. And we don't have 800 milliliter bags. So we can't prepare it exactly. So, so again, does all this make sense to both of you?
Yeah.
Yes. Yes.
Super, super.
Milli equivalents and units just throw me off for some reason. I freak out when I see them.
Yeah, ignore that. If it helps you to mentally just say, okay, that's same as milligrams, which of course, you know, technically it is not, but you know that milligrams or grams or micrograms or whatever weight standard of potency, they're going to disappear
Okay.
because we're delivering a volume. It's like going to, you know, it's like telling a patient, take 20 milligrams of, say, atorvastatin per day, and give them 20 milligram tablets. We don't tell them to take milligrams. We tell them to take tablets because that's what the patient actually receives. The fact that there are 20 milligrams of atorvastatin in that tablet is obviously critical, but it is not a part of the calculation. You know, so I really, you know, can't emphasize this enough. Don't get thrown by semantics, and to some extent, milliequivalents, milligrams, units. That's a semantic difference. They are a measure of the amount of drug in a unit volume of a liquid or a tablet or a capsule. Okay, does that make sense?
Yes, it does. Thank you for clarifying.
Oh, you're welcome. So let's look at this particular example, this problem here. Let's just go through this. Patient is supposed to get 500 milligrams of azithromycin over 4 hours. Okay. The pharmacy sends you 500 milligrams in 100 milliliters of normal saline. Well, the only point, we don't care, again, that this has 500 milligrams of azithromycin, because we're going to get the entire dose is going in over time. So the only thing we care about is this number of hours and this number of milliliters. So the flow rate is going to be 100 milliliters divided by 4 hours. Again, when the entire contents of a bag are going in, where we have in this example up here, which is kind of interesting, that we don't have, actually, yeah, we'll look at the units next. We'll go through that one next. But if you look up here, in this particular one, obviously the entire contents of the bag are not going into the patient. We will stop this at 8 hours. Could it be harmful to give the patient those other 2 milliequivalents? The answer to that is complicated, but in general, yes, it could. Because the physician has determined that what that patient needs is 8, not 10. Could the pharmacy have sent a bag that had 8 milliequivalents? Yep, in which case we'd give the entire contents. But that's not what the problem is. So let's go down here, 200 units of heparin per hour for 24 hours. Okay? So we have 200 units per hour. So 200 units this is the dose prescribed. Okay? This is the dose on hand, and this is Q. Now, it's entirely possible that when we get done looking at this content, that this bag will not last 24 hours. You don't care. If the bag is not going to last 24 hours, the pharmacy will send you another bag when this one is supposed to run out. Okay? So what we have is a bag here with 200 units per hour, 10,000 units in 1,000 milliliters. Okay? So we've got 200 units. divided by the dose on hand, 10,000 units, and then multiplied by 1,000 milliliters. So let's go ahead and pull up the calculator. And what I will do is share the calculator, since that doesn't come through unless I actually share it. So you can see the calculator, but probably can't see the other thing. But the calculation was 200 divided by 10,000, and that is going to give us that times 1,000. And so we get 20 milliliters per hour. Okay.
Yeah.
So that's the rate. Again, here we have calculated this based on the dose, because it is not clear to us that this is going to go in over 24 hours. In fact, if we divide 20 into 1,000, it's actually 50 hours. So it will last. But nonetheless, that's what we're looking at. So let's go back to this. Okay, does that make sense too?
Yes.
Okay, good. So that's how you use the dose, and that's how you ignore. You can't always ignore the drug. But again, note that we're dividing 200 units by 10,000 units, so that disappears.
Mm-hmm.
So again, you don't care what the potency unit is. It's
Okay.
just the way of measuring the amount of drug in a unit of dose or a unit of supply. Okay.
Okay.
So, and we'll run through the concept document in a few minutes. Days supply. This is a totally different topic, but it is something that we go through. The days supply basically is how long a medication will last. How many days will a medication last? When you get a prescription given by a doctor, if you're ever working in a pharmacy, you'll see this kind of prescription. The doctor might order a drug like Amoxil 875 milligram BID, and then PO, of course, we'll have it in there. The prescription will read Amoxil 875 milligram PO BID. And he might write down this number sign 14. That tells the pharmacy to give the patient 14 tablets. So if we look at this and look at the frequency, so we have the amount dispensed, which is the total quantity given, the amount per dose, the number of tablets per dose, times the frequency, how many a day. So we've got 14 tablets were dispensed. We've got 1 tablet per dose times 2 doses a day, and that should read 1 tablet. So we have 7 days supply of this drug. Okay. So if we take a quick look at one of these, a prescription for Haldol, again, the name of the drug is irrelevant. So all you're interested in is we want 1 milligram by mouth twice a day. The pharmacy gives 28 tablets that are 1/2 milligram. So we have to look and analyze this. The important thing is 1 milligram per dose, twice a day, and the potency on hand, the dose on hand, DH, is 1/2 milligram. So we're going to give 2 tablets per dose, twice a day, 4 tablets a day. So this would become, the formula here would, if we look up here, 28 over 2 tablets per dose times 2 doses per day. So we're going to have, again, 7 days worth of drug. Does that make sense?
Yeah.
Let's look at a volume because this is what throws people off a lot of times. And I'm going to give you a slightly different way of looking at this than you may get from others. But I think it makes it a little bit easier to handle. Remember that we prescribe in milligrams. We, for a liquid drug, the pharmacist will calculate the number of milliliters needed to fill the prescription based on the label strength of the drug and dispense the amount in milliliters, but he'll tell the patient how many teaspoons or tablespoons to take. That conversion isn't terribly relevant here because we will calculate everything based on the volume in milliliters. So we look here, the dose prescribed is 375 milligrams. The dose on hand is 250 milligrams, and the quantity is 5 milliliters. So here we're going to be dividing 375 dose prescribed by 250, the dose on hand, and then multiplying by 5 milliliters. If we do that calculation, 375 over 250 is 1.5 times 5 would be 7.5 milliliters per dose. Make sense?
Yep.
Okay. 2 doses a day is 15 milliliters. So we have 150 milliliters divided by 7.5 milliliters per dose times 2 doses a day, which is going to give us 15 milliliters. So we have 10 days supply. That clear?
Yep.
Okay. So use that. And I'm really going through this in detail because it's going to be important, less important, the assignment, this is to help you learn, but it will be important on the assessment because there are problems like that on the assessment. So let's I'll go back through a couple of other things. Quantity to dispense goes the other way. We have a lot of prescriptions are written in terms of an amount of drug, a frequency, a route of administration, and a duration. Okay, so we have a prescription components are name of the drug, amount per dose, route of administration, frequency of dosing, and duration of the prescription. Every prescription will have that. Even prescriptions for chronically taken drugs where you get a 90-day supply, they'll always be specifying either 90 days worth of drug or they will have calculated the number of units. So let's take a look. Amoxil 500 milligram BID for 7 days. Again, we need to know how many capsules or tablets in this case per dose. Dose prescribed, dose on hand, the vehicle or quantity, tablet. 500 over 250, 2 tablets per dose. 2 times a day, so we have the A amount per dose, 2 tablets per dose, times 2 doses per day, times 7 days, give us 28. Okay, so it's all worked out here. So it is fairly straightforward, but let's go to look. They don't give you a liquid, but that's what it works the same way for a liquid. Let's go up here and say and look at an example and maybe convert this to a liquid. If we and looking at this one, if we were 375 milligrams PO BID, 250 milligrams per 5, we do the same calculation, we get to 7.5 milliliters per dose, times 2 doses a day, times 10 days, and we'll come up with that 150 milliliters. So we can do, these things work both directions, and you'll see that, I think, in the assessment. Now, I went through the assessment the other day, and I will tell you that every answer in the assessment is correct. So if you get something that's wrong, you'll have to go back and note that. Now, when you're able to do the assessment 3 times, and if you do it a second and third time, which I encourage you to do, you'll get different problems. You'll always, the score that is recorded will always have the highest of the 3 tries. And I will go through and check, because if you've rounded things off differently or stated an answer slightly differently, it might grade you wrong when you're right. So be assured that I will go through each of your assessments with that in mind. Okay? Everybody happy with that?
Yeah, thank you.
Okay, let's take a 10-minute break. And then what I want to do is go back through the week 3 concepts that I used on Monday, and just go through those problems quickly, because they're a little more complicated. We can look at that, and I will, even though problems like that won't be a part of the assessment, but they're important things to know. So let's take a 10-minute break, and I'll pause the recording for that break, and then we'll do that, and then I will have you do the in-class exercise, work together on that for this week. All right? And I'd like to just pick up where on this document that is the week 3 concepts, which basically summarized what we've already talked about. But I wanted to go down to the problems here, and not necessarily solve them, but give you some information that really is needed to look at dosing calculations. The very first one is just a simple flow rate problem. I have the solutions here, and this is all posted in the resources page for this week. If we look at a drug that is, if you see something like 5 milligrams per kilogram, this is going to tell you immediately that you have to multiply this dose by the weight of the patient in kilograms to find out how much drug the patient is going to receive. In this particular problem, the patient is 176 pounds, which, if we remember that when you're converting pounds to kilograms, you're dividing by 2.2, this turns out to be 80 kilograms.
Okay.
Now, your patient weight can be anything. This could be, 78.6, but that's okay. We still use that as the weight. So when we are doing that, so we multiply the per kilogram dose by the kilogram weight. In this particular case, we get 400 milligrams. Now, we had 500. Now, here we have another example of drug where the total dose to give to the patient over this 8-hour period is less than the contents of the bag. So we have to plug this into our dose prescribed over dose on hand times the quantity. So we have 400 milligrams divided by 500 milligrams and then multiplied by 1,000 milliliters. So we're going to be giving this patient 800 milligrams over 8 hours. Now, quite frankly, if you wanted to solve this a different way, looking at and calculate the total volume, and looking at that rate, that's okay with me. I don't care how you get the right answer. I've said this to my students for years. There are lots of ways to look at calculations, and some people will develop their own means of solving problems. It is irrelevant how you get to the right answer, as long as you get to the right answer, because that's what the patient needs. In this case, we find out that we want to be delivering this at 100 milliliters per hour. 8 hours, we're only going to use 800 milliliters, but that's okay. Okay. So we know that this patient's going to receive this 800 milliliters, but we're told that it's going to happen over 8 hours. So we just calculate it that way. Now, we can also have situations in which we're supposed to deliver a very small dose per kilo per minute. So again, we've got two things to think about here. We've got, if we're using a pump, we want to end up with a dose per hour. So we know that if we see micrograms per kilo, we know we're going to multiply that by the kilo weight. So we convert that, we get 60 kilograms. The patient weighs 132 pounds. So we know that we're going to get 150 micrograms per minute. Now we can stop there if we're going to be calculating, a manual flow, but we're told a pump. So we convert minutes to hours. So then we've got 150 micrograms a minute times 60 minutes per hour. That's going to be 9,000 micrograms per hour. Don't get bothered by big numbers. Calculators don't care how big the numbers are. Okay, so don't worry about that. I urge you, using a calculator, by the way, to do every calculation at least twice to be sure that you have it, that you have it correct. So now if we use this dose prescribed times the quantity divided by dose on hand, we've got 9,000 micrograms per hour. That's the dose prescribed. That's not what it says here, but we've calculated that that's what it turns into. Okay. So we've got the drug in 50 milligrams of this drug in 500 milliliters of, in this case, dextrose 5% normal saline. So we have to convert the milligrams to micrograms. So now we have another big number, 50,000, but again, we don't care. Our calculator doesn't care. So we simply set this up. We calculate 9,000 micrograms per hour divided by 50,000 micrograms times 500 milliliters. 90 milliliters per hour. Okay. Make sense?
Yes.
Kayla, are you happy with that?
Yeah.
Okay. Now, you can look this over. You can download this and look it over, or not even download it, just open it up. And I have also had these things done in using manual delivery. So in this particular case, in the first problem, which was giving 125 milliliters per hour, we can convert that to milliliters per minute by simply dividing the 125 milliliters per hour by 60 minutes per hour. We end up with 2.08 milliliters per minute. Again, do not round that off. If we are using a 15 drop per milliliter set, We multiply that by 15 drops per milliliter, and we get 31.25 drops per minute, rounded to 31.
Okay.
There are people who will say you always round up no matter what this is. Please don't do that. You
Yeah,
introduce,
no, I would keep it at 31.
keep it at 31. So in problem 2, we calculated that we're going to give 100 milliliters per hour. But in this case, they want us to use a 10-drop set, 10 drop per milliliter set. So we divide that 100 milliliters per hour by 60 minutes per hour. We get 1.67 milliliters per minute. Multiplying that by 10, we get 16.7 drops per minute, which we, of course, translate to 17. Problem 3, we're going to use a microset, 60 drops per milliliter. Again, we started at 90 milliliters per hour. Divide that by 60, we get 1.5 milliliters per minute. Now, if we multiply that by the drop factor, we get 90 drops per minute. Note that when you are using a microset, the drops per minute is always equal to the milliliters per hour. If we look at the math, we're dividing by 60 and then multiplying by 60. So that's another fact, that mathematical fact that comes out of these kinds of calculations. If we're using a microset, and we can either convert to drops or milliliters per minute, or we can just stop at milliliters per hour and just convert that straight to drops per minute, because that mathematically is how it works out. So that was the reason that we have problem number 6 down there. Okay, is that everyone happy with that?
Yep.
Kayla?
Yeah.
Okay, so let's do a new share. And we want to go here. No, I don't want to go there. I want to go here. Okay, so we want to go to the in-class activity for this week. When you download this, Kayla, you'll see this screen. Ariel, you'll actually see a screen with the title of the document, but it's the same document. So
Okay.
I want you to go ahead and download the document. And what I will do now is actually pull that up. If I can find it. Okay. So your in-class activity consists of 8 questions. What I want you to do is remember the things we talked about earlier and solve these problems. I'd like the 2 of you to work together. What I will do is mute myself, because we still have a lot of background noise in here. And I will pause the recording. If you have questions, just speak up. I will start the recording again and talk to you. And I want to start the recording so you have a record of our conversation as well, if you want to look at the recording in the future. Okay?
Okay.
All right. So
Really quick, Mike, I tried to download the week 3 concepts. And it says unauthorized.
What?
Yeah, it's being kind of weird.
All right.
I click on it to just view it, or to even download it, and it states it's unauthorized, and it takes me to like its own web page.
That's strange. Kayla, can you try and download and see if you can?
I was just going to say, which one are we supposed to be working on together?
The week 3 in-class activity.
I'm getting to it right now. One
Okay, if you
second.
go to resources though, first, would you see if you can download the week 3 concepts document?
My internet's just slow, so it'll be a second.
Okay,
No problem.
That's one thing about living in the middle of nowhere is like, I don't know, you'd probably get better internet sitting in the middle of the Saharan desert. Like, I don't
Yeah.
know.
yeah, yeah. And since Elon Musk's Starlink isn't up yet, it's going to be that way for a while.
Oh.
Uh, so the week 3 assignment,
No, in resources, the download the week 3 concepts
resources.
document. Which is this document that I have on the screen at the moment.
I'm getting to it. It's like it gets slower when I actually need something.
That's technology at its finest.
What was that, Kayla?
My internet just gets worse as I need something.
Yeah.
All right, I'm going to week 3, and it's gonna say week 3 resources on it.
Yeah, the week, open up that page and then you'll see the last entry will be week 3 concepts. With answers.
Okay, clicking on it, processing, connecting, processing. Clicking on it again. I don't know what it's doing. It just disappeared. Try this again. Click on it again. Here it goes. Oh my goodness. Been trying to start for the past like 2 minutes, but I think it's on to something. Okay. Yeah, week 3 concepts, day supply and all that stuff.
Yeah,
Okay, it loaded.
it loaded. Okay. All right. Well, thank you for that. Ariel could not for some reason, so I will just email her a copy of that document, but you have it. So let's go
And then
back.
what else do I need to open?
Sorry?
What else do I need to open? Sorry for interrupting.
You'll need to then go to the week 3 in-class activity page back in the week 3 module, and open up the document there. What you'll see is there will be, download here, and here for you will actually be just highlighted as a downloadable document, and you should be able to come up with the in-class activity.
All right. Pulling that up right now. Oh my goodness. Okay.
Okay, you able to get it downloaded, Kayla?
I'm clicking on it now.
Okay.
Sorry.
No, that's all right. Yeah, you're kind of out and away from a major market, in a beautiful location, but a little bit isolated.
Yeah. We have like a Walmart here and a Safeway
Oh,
and a lake. That's all we got. Pretty much.
that's a lot bigger than it used to be.
Yeah, yeah. I know my great grandma was here like when the first gas station came here and stuff.
Ah, yeah.
They would have to take they would pick the cars up like to this like line and take it over the like big canyon
Mm-hmm.
and that bridge. I hate that bridge. Okay, it worked. It worked.
Okay, great. All right. So, so the two of you go ahead and work together on this, help each other. And what I'm going to do, Ariel, I will email you a copy of the week 3 concepts. That's just the easiest way to do this at this point.
Okay.
And so go ahead and work on this together. I'm going to mute my microphone and pause the recording. If you have questions, just speak up. I will start the recording so that we can have a record of our conversation. And then I will start, then I'll mute myself again. So, so have fun with that, and let me know if you have any questions.
Okay, sounds good, Mike. Option 1, when we're talking about milligrams per kilogram, is this going to be like a liquid, or does that not really matter?
It doesn't matter.
It doesn't matter?
Just asking how much drug is needed.
Okay. I'm just trying to make sure that I'm doing this correctly.
And don't get worried if you get a big number.
Okay.
There are drugs that are dosed in multiple grams per dose. So even though they're relatively rare, but certain antibiotics like ticarcillin can be up to 4 grams a dose.
Okay.
Okay, so I'm going to pause again.
Okay. That's what I'm assuming. But I feel like that's wrong.
I know that's what I do, but I don't,
Okay, so how are you getting to that number?
because we did the 24 times 77, and we thought every 6 hours, divided
Ah.
that number by 6.
Note, per dose. It's not a divided dose. It's per dose. So this is telling him he's going to get 24 milligrams per kilogram every 6 hours.
So per dose would be the 24 milligrams times 77 kilograms,
That's right.
which would equal 1,848 milligrams per kilogram.
Not milligrams per kilogram, milligrams per dose.
Okay. Okay. I think I'm reading into it too much.
Yeah, so why do they put kilograms there then? What does that even do for us?
Ask again, Kayla.
Why do they put the milligrams per kilograms? Like, what does that even have to do with anything?
These are generally, when we dose by weight, they're generally drugs that will have what we call a narrow therapeutic window. In other words, a drug that the dose where toxicity is uncomfortably close to where the effective dose is. And so what we do is then this allows us to give the dose that the patient needs safely. And is so when we have drugs like that, then what we're doing is admitting that we can't use fixed dosing for our patient. And fixed dosing is like getting a tablet of 100 milligrams and giving that to every single patient, whether they are 50 kilograms or 250 kilograms. It doesn't matter. That's a fixed dose.
Okay.
So where we run into this is drugs that we don't want, that we can't really give fixed doses to. Does that make sense?
Yeah.
Yes.
Great.
So our answer would be the 1,848 milligrams per dose.
That's right.
Okay. Okay.
Okay.
I'm reading into it way too much.
Now, don't overinterpret.
Girl, don't do that.
It's easy to do.
I do the same thing every time.
Yeah, that's those kinds of issues. As a rule, we don't like to have patients taking too many units at a time because compliance goes down, but occasionally that has to happen. Years ago, when my father was still alive, he called me up and said, I'm supposed to take 1,000 micrograms a day of vitamin B12, and I can only find 100 microgram tablets, and the pharmacist says I have to take 10 at a time. Is that right? And I said, yep, Dad, enjoy your breakfast.
That's how they had me on vitamin D when I lived in Colorado as well.
Yeah.
Oh my goodness.
Yeah.
I couldn't imagine taking 10 of the same pill.
That would drive me crazy.
That would drive me nuts as well.
It does reduce compliance. Now, my dad is ex-military, always did what he was told.
Okay.
So he didn't have a problem with that. But I know a lot of people that would just say, nope, not going to do it.
Oh, I can definitely see non-compliance happening.
Yes.
Okay.
Eventually, my brother-in-law found him a bottle of 1,000 microgram tablets, which he was very happy with. But it is not. It's unusual, but it is not. It is seen that sometimes we have to take a number of these. Usually, these are going to be short term.
Okay.
Okay. Are you ready for the next one?
4.
That's
Is
what
that-
I had in mind.
Oh.
Was to show you that these things will give us different results.
Okay.
Okay. Just because of the different nature of their rules. Those results are fairly significantly different. Here, the difference between 67 and 74 is 7. So that's more than 10% difference between the two. So we would then probably want to consult with our primary as to what would be appropriate. Our primary meaning the practitioner with whom we work.
Okay.
But that's to show you that these things don't give us the same answer. They can under the right circumstances. But what we're seeing is a case of this is a child at 40 pounds in 5 years. That child is small.
Very small.
Yeah. And so in that case, it would tell us that we would probably want to use the Clark rule as a better measure of the size of that child.
Okay. Okay.
Okay.
Cool. So you just want us to put, or
Yeah.
do we just put them both? Yeah.
Yeah.
Okay.
Yeah, that's it. That's what I wanted you to do.
You ready for?
And the pediatric, okay, so this is a pediatric dose. So I am assuming we would use that nomogram from the week 1 assignment. No, it was week 2.
Yeah. That's what I have in mind.
Okay. 'Cause we need to-
That's easier than going through the calculations. And quite frankly, it was very carefully constructed to give us these two different columns on the nomogram itself.
Okay.
Okay.
Perfect. Because we can plug in that body surface area. I lost my week 3 assignment, or in class.
Well, you don't have the height. Normal height is a range.
Okay.
So, so it's falling within the normal range for that weight, but you don't have that. So you would use the nomogram always in that case.
Okay. Okay. Let's get a sheet of paper. Messages with what they're giving the patient have to go off of body surface area. I might be wrong.
No, that's correct.
Okay.
There are a few other drugs that are dosed that way, but mainly these are used for cancer calculations, these nomograms, these body surface area calculations.
Okay.
And Kayla, if you look at that, there are two charts in that on the last page of the week 2 assignment. One is for adults and the other is for pediatrics. The pediatric chart gives us two different ways of looking at this. If we have children who are normal, and the children vary all over the map. Sometimes they will be small and sometimes they will be larger than average for their weight. So we have a line for normal height and weight children, and all we have to do is read the weight in pounds, and straight across on that chart, that the other on the right side of that particular line gives us the surface area for that child. So if you are told that they are of normal height and weight, you can use that. If you are given a height and a weight, don't assume normal. Just go ahead and connect the height on the far left with the weight on the far right, and then we have the other line that reads surface area, the one that is SA, which is the one on the right of the two. And wherever that line that you draw between weight and height crosses that bar, that's the body surface area. And with the adult, it's the same way. You connect weight and height and just read it off the chart. Okay, does that make sense?
Yeah.
Okay.
Okay. Right. 0.6. Wait, am I doing that wrong, Mike?
Yes.
Okay.
You would be multiplying by the dose per meter squared. So
Multiplying. Okay.
body surface area multiply by the dose per meter squared to get a dose for the patient.
Okay. So it'd be 60 times that 0.6. Okay. So I got 30. Okay.
Yep,
Okay. Perfect.
36 milligrams.
What does the B stand for again?
The V is the volume in milliliters. So that would be the 500. But
Over time. Yeah, that would make sense.
okay. Well, my only question now is 45 minutes is less than an hour. So how would we get milliliters per hour?
Well, okay. You can divide 45 minutes divided by 60 minutes per hour will tell us how many hours that is. It can be less than an hour.
Okay.
Just turn that into a decimal.
Yes.
So would that be 0.75 then?
Mm-hmm. Yep, that's right.
Okay. 500 over 0.75. Where was that? Oh, that gives our flow rate. Aerial. Is that what you got? Or are you doing the minutes?
I did the 500 divided by the 0.75 and I got 666.66.
That's what I got.
I don't like those numbers.
So I would round that up. So I would get, I don't like the 666 number, the digits. So milliliters per hour is what that one is, I believe. Yes, that is the one per hour.
Yep.
Oh, okay.
It's a crazy number, but if you were using a manual set, you'd have to calculate that anyway.
Okay. So I would round it down to just 11 milliliters per minute then.
Okay.
That's what I would leave it at.
Yep. If you think about it, that's 1/10 of a milliliter out of 11. That's a very small error.
Small window. Okay.
Like
Perfect.
1%. So not a problem.
Okay. Awesome. Now for number 6. Ah. Oh, I see. Moved on to the next page. Order is for D5W to be delivered at 80 milliliters per hour. It is to be administered through a venoclesis set or Clysis set rated at 15 drops per milliliter. Okay, so we just have to find the drip rate. I think that's the volume. The drop rate where it's the V over T times drop factor. Okay, so we have to convert that hours into minutes. Is that what we need to do first? 80 milliliters per hour. So it doesn't give us. So 60 minutes is 1 hour. Okay. Again, I'm reading too much into that.
So how are you writing it down?
I was going to start with, if I can find it again. It's 80 milliliters over 60 minutes.
Okay.
So 80 divided by 60 gives us 1.3 milliliters per minute, what I got. And then we need to multiply that times 15 drops per minute. Minutes will cancel out. I got 19.5
Same.
drops per milliliter. Is that what it is? Yes. So I would round that up to 20 drops per minute. Or milliliter, I'm sorry.
Okay.
Grams of drug C over 10 hours. The drug is delivered from the pharmacy and is labeled drug C 500 milligrams.
Would it be the volume over time equals flow rate?
So would we be taking the 1 liter?
Yeah, take a look at this particular question, and it goes back to something that I brought up before. We are giving the patient 500 milligrams of drug over this 10 hours. We're supplied that total dose and this volume. So the only thing we care about is we're delivering the entire volume of this bag over 10 hours. So the 500 milligrams is irrelevant in this case. What we want to be looking at is the fact that we're going to empty the bag. We're going to give the entire contents.
That's all you have to know then?
Now, excuse me, Kayla?
That's all you say, like, is they're gonna use the whole bag within the 10 hours?
Yeah.
Oh, okay.
So again, look at the question and say, what is it? What is the flow rate? Okay, we want to know the flow rate, and that's volume over time. And so we look and see if the volume is already specified for us, which it is, because we're
1 liter.
the entire amount over that 10 hours,
Okay.
right?
So that 1 liter is the amount, correct? Like the full amount?
The volume, yeah, that's V.
Or the volume,
Yeah.
which is 1,000 milliliters.
Right.
We divide that by the 10 hours.
Yep.
So that would be 100 milliliters per hour.
Right.
Okay.
Is that what you're getting, Kayla?
What did you say at the end?
I said for the answer or for the equation?
For the answer.
For the answer, I said 100 milliliters per hour. Would be 1,500 milliliters, I believe. We're moving that decimal 3 decimal places to the right. And it's it's over 5 hours, so we have to convert that to minutes.
You're converting what into minutes?
The 5 hours,
Oh, okay.
which would be 300 minutes, because we're doing that drop rate formula where it's volume in milliliters over time in minutes. And so 1500 divided by 300, I got 5 milliliters per minute. Did you get the same?
Yeah.
Okay. So now we have to figure out the drop rate. So that's the IV is, the IV set's rated at 15 drops per milliliter. So we take that 5 milliliters per minute and multiply it by the 15 drops per milliliter. So 5 times 15 is, I got 75 drops per minute. Do we have to worry about the 300 milligrams?
The answer to that is no, since again, we're looking at the dose that the patient is going to receive. This patient will receive the entire
Bag.
bag,
Okay. So I was right in thinking
5-hour
that.
time period.
Okay.
So, go back and look at the logic. One of the first questions you need to ask is, if the patient is supposed to receive this amount of material, is that what's in the bag, or is there a different amount? If it's a different amount, then we have to go back and recalculate using, once we calculate the rate based on the volume, go back and calculate go back and use the D times, or D times Q over H formula. But in this case, we're using all of it. So again, we've taken the drug out of the equation
Patient.
entirely,
Okay.
because it's just a volume over time.
Okay. So were we correct when we switched the liters to milliliters and divided that by minutes?
Yeah, you have to,
get-
because it's all milliliters. All the dosing is either milliliters per hour or milliliters per minute.
Okay.
Okay.
Okay. Well, I feel pretty confident in my answer now.
Great.
I'll go ahead and just get that here. It's 75 drops per. I think that was it for. For the week 3.
Okay, so both of you just go ahead and submit that,
Okay.
so that we'll have that in the grading system.
Okay.
And then,
Sure.
we still have about 15 minutes. So um, why don't you go ahead and do some of the work on some of the discussions that are still to be turned in. Okay.
Okay.
And then I'll be here for the next 15 minutes or so
Okay.
to answer questions. All right.
Sounds good.
And then just before class ends, I'll have some hints of some things that you need to do to get prepared for next week, which is the end of the class.
I know. I can't believe week 4 already.
Yeah.
Classes just fly by anymore. Thank you for throwing everything on the floor.
I'll be right back. I'm gonna go to the restroom.
You just throw everything on the floor, Bella. You're so funny. She looks tired. Oh yeah? Yeah, sounds like a very tired boy. I think somebody's trying to pass something along there, huh? Okay. Which fiber? There's just some bananas and stuff. Hey, Mike, I do have in regards to, I'm just finishing up a couple problems on the week 3 assignment, and it was regarding the calculating quantity to dispense. So it's down at the bottom on the week 3 assignment. So when they say a patient should take something every 4 hours, so that's 4 hours within a 24-hour period, correct?
That's correct.
Okay. So every 4 hours, that would be 6 pills, right? If like, because I'm just trying to calculate that to where, like, if somebody started at 6 a.m. and went to 6 a.m. the next morning, that would be 6 capsules or tablets, correct?
Right.
Okay. Okay. I'm just trying to make sure my theory that I'm thinking of is correct. Okay.
Okay.
Thank you.
You're welcome. Yeah. Kayla, are you back?
Yes, I am.
Okay, so I just wanted to say something about next week before we end the class, which it's about time to do that. next week's assignment requires that you use EHR Go. I assume both of you have logged in and have your EHR Go account.
Yes.
Okay. So the assignment itself is going to be to look up and write a script for one person, and then a letter for another. So keep that in mind as you are looking at those records. How are you going to explain the issues to the patients? You got two different patients, so there's two parts to the assignment. Okay.
Okay.
All right. So it's going to be an EHR Go thing, and we may or may not have an in-class assignment since we are actually going to be finishing out the class on Wednesday. I haven't decided if we will do that. If we do, it'll be something probably related to the administrative duties you might have to engage in working in a practice. And if it's not, then I'll pull it out, and that won't be a problem.
Okay.
Okay. So try to get all your work done. We're closing in on the end of this class, so try and catch up on the work by the end of the weekend, so that we can get this all done next week. Keep up with your daily checkpoints.
Okay.
And have a good weekend. Again, if you have problems, if you need to ask questions, you can email me. If we need to speak more directly for any reason, let me know, and we'll set up a time to do that.
Okay.
Okay.
Sounds great, Mike. Thank you.
You're welcome. Are you set with all of that, Kayla?
Yeah, thank you.
You're welcome. Well, everybody have a good weekend. Take care of yourselves, and I'll see you on Monday morning.
Thank you. Have a good weekend too.
Ariel, do you
Yes.
want to exchange numbers in case that we have questions? We could just talk to each other.
Sure. That sounds good to me.
Okay. What is your number?
Mine is 970-590-8575.
Okay, I'll text you right now.
That always helps too.
And now, like, sometimes I'm like, oh my goodness, I don't know what the heck I'm doing. I don't want to, like, book Mike all the time.
Well, that's what I'm here for.
Yeah, you're going to be like, how the heck is she even, who is she?
No. You're doing fine.
Okay.
You're doing fine.
All right. Well, thank you guys.
Of course.
Okay, I'm going to stop the recording and close the class. So everyone have a good weekend.
You too, Mike. Thank you.
You're welcome.